Hello, everyone. My name is Gökhan Uluderia. I'm a principal program manager at Microsoft Azure Machine Learning team. And today we also have Jack Shea and Nick Gaylord from Crowdflower. Nick is a senior data scientist, and Jack is the VP of product at Crowdflower. Thanks for joining us today.
Thank
you. Today, we're actually going to talk about how to build real-world analytics applications combining machine learning and human intelligence together. So we're not just going to talk about it. We're actually going to walk through an end-to-end sentiment analysis application that Crowdflower team built for us using Crowdflower AI and Microsoft Azure Machine Learning. All right, let's go to the slide. So if you had a chance to watch Joseph Sirosh's keynote yesterday, you kind of heard about Microsoft's vision and effort to make machine learning simpler, better, faster, and more accessible through Cortana Intelligence Suite. And you also had a glimpse of how Crowdflower and Azure Machine Learning team are actually partnering together to achieve that goal, kind of democratize machine learning. Combining machine learning and human intelligence allows us to build not only powerful and more accurate models, but actually models that learn and improve over time, leveraging human insight. So today we will get into a bit more details around the partnership and the integration, and also talk about the opportunities that lie ahead of us as data scientists and application developers. Let's start with a simple example. Let's remind ourselves what photography used to be 20 years ago. I'm sure you were taking pictures 20 years ago. I was, but you were kind of using a heavy, bulky camera with many knobs and lenses. And you would spend days probably learning about the machine itself. And then when you were ready to take a picture, you would actually spend minutes just configuring it to take a good shot. Well, was there anything called instant preview? Well, the instant preview was actually waiting for a few days, going to your favorite store, and actually taking a print. Well, today we're basically taking many, many higher quality pictures with just press of a button on our phones, right? And we're not only just taking pictures, actually, we're looking at them immediately, instantaneously. We're also sharing them with our friends and family. We're uploading them to the cloud for anytime, anywhere access. All of that actually happens in seconds. 20 years ago, photography required a very specialized skill set and knowledge and a tool set. Well, today we have a beautiful ecosystem around pictures and wonderful set of experiences. We don't even think about what we used to do 20 years ago. So machine learning today, it's actually not that different compared to what photography was 20 years ago. We do actually, well, if you want to do machine learning and data science today, you do actually need a very specialized skill set and knowledge and a specialized set of tools. And let's be honest with ourselves, we actually do go through a very cumbersome set of steps if you really want to build an end-to-end solution together. So we run into this really interesting problems, whether it's in the data labeling or data enrichment phase, or modeling or labeling or operationalization. Operationalization generally is one of the trickiest problems with machine learning and data science. So when we look at the photography example, we really draw our aspiration from the camera example. And day in and out, we're actually trying to build seamless, powerful experiences into Cortana Intelligence Suite to basically make every step in the way a lot simpler than what it is today. If you look at the evolution of Azure Machine Learning, you'll realize that we're actually building very powerful, intuitive capabilities into the product and constantly building this in to make machine learning truly simpler, better, faster, and more accessible. Starting with simple interfaces in Azure ML, we are building a service that lets you kind of do automatic featurization. That lets you try different models and different algorithms and pick the one that gives you the accuracy that you need. And also operationalize through a powerful service backend with a few simple steps. With Azure Machine Learning, you cannot just build a model and deploy it in a few steps, but actually retrain, redeploy without disrupting your existing users and applications. And you also have web service endpoints that actually make your machine learning models easily consumable by your apps and users. So obviously, this is going to be a journey for us, and I hope you'll join us in that journey together. But we have very ambitious goals to build the best-in-class products and experiences in Cortana Intelligence Suite and Azure Machine Learning. And part of achieving that goal is really integrating well with other services and capabilities that you use and love. So Crowdflower is a very popular tool today, a popular data enrichment and labeling platform for data scientists. And combined with Azure Machine Learning, it actually gives you the ability to inject human intelligence and human insight into your workflows. In a world where Azure Machine Learning provides the ML algorithms and the underlying feature engineering capabilities, Crowdflower lets you integrate humans into your applications and workflows and continuously improve your applications, combining these two powers together. So all that said, I'm going to turn to Nick and Jack, and they're actually going to show us how they built an airline sentiment analysis application end-to-end using Crowdflower AI and Azure Machine Learning. Nick?
Thank you very much, Gökhan, and thank you all for coming. It's great to see you, great to be speaking here today. So we're going to be talking about sentiment analysis this afternoon. And this is actually one of my favorite text analytics applications. In addition to being a data scientist, I'm also a linguist. That's what I got my PhD in several years ago. And I'm really fascinated about the nuances with which people express themselves and what they're thinking and what they're feeling. And so that's one reason why I chose sentiment analysis as a use case to walk through, is just because I like it. It's also a hard task. And it doesn't necessarily seem like it should be on the surface. You know, the typical idea behind, the conception behind sentiment analysis is something like, hey, I've got these documents, I'm going to go through them, and I'm going to count up how many, I love this, I hate that. But it's not really, that's not really the meat of it, because people don't usually say, I love this, or I hate that. It's much more nuanced, it's more subtle. You have to read between the lines and infer what people are really trying to communicate. So that makes it a challenging problem to classify those texts appropriately. And the third reason why is that sentiment analysis is important. Brands need to understand what their customers are saying about them. And social media provides a large, low-cost, extremely timely source of data for learning about these questions. So those are three reasons why we chose sentiment analysis today. If I'm, for example, a major airline carrier, maybe I'm Delta Airlines, and I want to understand how to improve my service, if I want to understand if there are any urgent customer service issues that need my attention right away. These are the type of resources that are going to help me power those business decisions. But on the other hand, we might say, hey, there's a lot of sentiment analysis tools out there on the market already. So why are we continuing to talk about innovating and building new ones? In fact, those of you who were here for Joseph's keynote yesterday morning saw a very cool demonstration involving sentiment analysis on this stage. Well, the thing is that off-the-shelf sentiment analysis resources, they tend to be pretty limited. On a lot of data sets, most of them max out somewhere around 70% accuracy. And so, okay, why is this? Well, there's a couple of reasons. First of all, fundamentally, sentiment analysis is a difficult task. For one, we are taking what is really a pretty continuous thing, how I feel is a spectrum of attitudes, and we're binning it pretty coarsely into something like positive, negative, and neutral. And so that's going to mean there's a lot of edge cases. There's a lot of potential for humans to disagree on the particular tone or sentiment of a piece. That can make training hard, that can make evaluation hard. But the real issue, the biggest issue, is one that we see implicated in text analytics projects all over the place, and really machine learning more generally, which is the issue of domain differences. A model that's trained on one set of data will often suffer performance losses when it's applied to a dissimilar set of data, and sometimes those losses are precipitous. Right? So what form does this take in the context of sentiment analysis? Well, like we mentioned before, sentiment analysis is not really about I love this, I hate that. It's about these more implicit cues. So we can consider a word like thin. And I can ask you, does thin convey a positive sentiment or a negative sentiment? Well, often we will probably think of it as saying something positive, right? In the context of lifestyle, health, and beauty type magazines, it's this very aspirational term. If I'm thin, I'm attractive. If I'm thin, I'm healthy. We want to be thin and stay thin. But that's not always the case. Right? If we look at what travelers are saying about their experiences, whether that's hotel reviews or, in our case here, airline passengers, turns out that thin is often something much more critical, where people are tweeting about their patients wearing thin as they're waiting to board a flight or take off. They're tweeting about thin blankets or thin seat cushions or thin curtains separating first class from the rest of us. So the point is, right, these two industries, they shouldn't be using the same sentiment analysis tool to understand what their customers are saying. And that means that you need something custom and in domain. And we know this because sentiment analysis at Crowdflower is actually one of our core 8 use cases that our customers come to us for help with. What you see on the screen here is a job monitoring dashboard for an actual job run on the Crowdflower platform, collecting some data about sentiment on social media about major airlines. This is, by the way, a small job by Crowdflower standards. The customer here has gotten about 12,000 human judgments in about 2.5 hours for $135. And so that is a pretty substantial data set. That's enough to do some real-time analysis of what your customers are saying, but that's also enough to consider starting to build a machine learning model so that you can actually have tailored sentiment predictions available to you at your fingertips without having to run these jobs every time. So that's what we're seeking to build today. So as somebody working for, say, Delta and looking to build one of these sentiment models, what are the requirements that I have? What are the key ingredients? Well, I'm going to need some raw data to analyze and to label. I'm going to need human labels on that data. I'm going to need people to mark whether this is saying something positive or negative. Once I have that labeled data, I'm going to need access to a suite of NLP and machine learning tools so that I can actually build models from that data. And I'm going to need to be able to evaluate those models and see how they perform. I'm going to want to be able to iterate on that training process using humans in the loop so that I can eventually get my model customized and trained to a state where it's really useful to me. And then once I reach that point, I'm going to want to make it easy to deploy that model into production and actually put it to use. Crowdflower AI, the solution that we're talking about here today, covers almost all of these key ingredients, except BYO data. If you have data that you want to label and you have data that you need to analyze, it provides the remaining tools and resources that you need to actually build a functional product. So to take all of this and make it much more concrete, I'm going to hand things over to Jack now, and we're actually going to walk through the process of doing this end to end. So if we can switch to demo now, please.
Yep, I don't need that.
Oh, right.
Thank you. Also for the, I'm Jack Shea. I'm the head of product at Crowdflower. Thank you to the creators of the PowerPoint template for that beautiful Ken Burns animation into my demo. I appreciate that. This is, as Nick mentioned, the 8 core use cases that Crowdflower services. You can roll your own. You can start from the beginning. We can help you with other things, but sentiment analysis is bread and butter. And if I'm, let's say, that data scientist at Delta Airlines and the business wants to both track social sentiment and categorize those tweets, those Facebook posts, whatever you might have, into certain buckets of customer service issues, and they want to benchmark that against competitors over time, that's going to be a sentiment analysis task, but I know that there are also templates under our other use cases, data categorization maybe, or even possibly image annotation that might be useful approaches for me to take. This one, however, is fairly standard sentiment analysis, so why don't we just start there? So I'm going to go ahead and click that, or Nick is, either one. And from there, I am presented a number of different approaches that Crowdflower recommends, kind of basic out-of-the-box approaches to sentiment analysis. For instance, if I was at American Airlines, I might need to filter out a bunch of things for irrelevant tweets or posts, the word American, of course, being pretty important these days. But for Delta, let's say I don't have to do that. I can look at these approaches. I can preview maybe one of them. That one certainly, that top one's going to ask me, is ask the questions I want. Right here, I have an overview of the job. This is what the human contributors that will help you label this data at scale are going to see. Basics on context of the job, the exact steps they take. We recommend rules and tips around how you guide them to classify things. And then, of course, some examples always helpful. As I scroll down, and these give you a good start. You can obviously customize from there. This is the kind of question I want to ask. It's radio buttons. That makes sense. I think I can go ahead and use this as a start. So from here, I've got a template to start with, and I can start designing that, but I also want to add data. Now, I don't want to spend the time. We're in the business of giving data scientists their time back. Don't want to spend time doing a bunch of ETL out of our social listening stuff, and a sample CSV might work. But in this case, since Twitter is going to be at least part of the data set here, we have a handy-dandy widget for importing from Twitter rather than just taking a straight upload. Click on that. And from there, this is great. This is just native Twitter API functionality. After you connect your account, it takes Boolean operators, so I don't want the retweets. Those are just more of the same, really. I'm not doing an analysis that's sort of looking at amplification. So I get rid of the retweets. Look at Delta. Let's see about ours. Did you guys all enjoy your flights in on Delta to Atlanta? Here, maybe some of you are in this data set. Let's see. Yeah, nothing too bad. Generally, what I expect, not a whole lot of noise. That's good enough for me. I'll import those tweets. And move on to designing my job while the tweets load in the background. If you've got a big data set, that can be helpful. And from here, I'm presented with the basics of the template that I selected in a graphical user interface for editing the initial job that's going to go in this human-in-the-loop workflow that I'm standing up. So this is the initial thing. I've got my presentation of data. The template's done a nice job of displaying the tweet out of the box. But remember, I have those two questions I want to ask. One is it positive, neutral, and negative? But also the other one is what kind of customer service issue I might have. So I'll add that question. And in this case, I think for this analysis, I want the best answer, not what all could apply. So multiple choice probably sounds right. Rephrase the question. What's the nature of the customer complaint? Some of the labels could be baggage, delays, customer service, that sort of thing. And remember, of course, I don't want to ask this question of anything. I only care when it's relevant to those sort of negative tweets. So I'm going to use this conditional logic feature. Add the trigger that says only when that parent question of positive, neutral, negative is negative do I want to ask this follow-up question. I'll add that. And from there, let's say we've got this form design generally good. We'll scroll down. We would customize questions. Again, apply those examples and instructions. After you've got that form sort of where you want those to match. And if you guys like cooking shows, I'm going to do a cooking show trick, which is from here, I'm going to put this in the oven and then pull out a preview of the finished job. That wouldn't take much longer, actually. But in this case, just to remind everybody what it is we're asking the machine to model eventually, we've got the process. We've got how to determine positive, negative. This all looks good. These are my, so scroll down. And here are some examples of tweets I've embedded as like positive, neutral, negative. And then from down there, let's see, positive, neutral, negative are there. And then if I expand just to make sure that negative one does what I expect, there we go. Those are my categories. This is good. So from here, I'm also going to train the contributors based on quality settings that I configure, what my definition is for this analysis of how I want these questions answered. So I'll do a couple of example rows just really quickly. It's sort of 8 in the case of this is all we'll need. And what that does is pre-screen contributors who can't get those answers right, they're not reading the instructions fully or fully understanding them. We continue to train them over time by inserting these sample questions and giving them answers to maybe important edge cases, those sorts of things. And then, of course, if those people are not at an adequate level of accuracy that I configure, then at that point, we're going to remove them and then replace their judgments with more trusted judgments from people who are successfully staying above my quality standards. Now, in this case, this is sentiment analysis. I'm doing it for domestic airline carriers. Maybe I'll target contributors in the US, but you can make the contributors whoever you want. If it's a sensitive job, for instance, and you only want your internal staff doing it, we provide that feature. We also have channels we work with that have contributors and companies who have signed NDAs around and have physical data security. So it's really whoever you want it to be. I'm going to pull this out of the third oven here and finish the job magically. But as you see, I'm not going to make you wait for an hour and a half, but we would have only had to wait about an hour and a half. We're spending less than $200. We got 3,312 rows labeled. I set it to be 3 judgments per row, so I've got that aggregated wisdom, human wisdom, sort of rolling up to each row. That's why there's 9,000 judgments. And a couple of folks did fail out of that thing, and that's all fine and great. I've replaced their judgments. But from there, I don't want to just stay. This is my butt on the line with this analysis, and so I'm going to go ahead and spot check this data before I would ever run it through a model. And some of the ways to do that would be, for instance, in our this is that aggregated report of those judgments by row. I can run a quick pivot on here. Expect how many folks are in the Microsoft ecosystem here? Just a show of hands. Yep. Okay, so you know about pivot tables. And I learned from the best. And here I can just get a look at the data distribution, more negatives than positives and neutrals. I probably expect that. And then those reasons underneath that give me a sense of sort of what the data is doing. I can download this report and run further analyses and visualizations if I want. Let's say I'm happy with that, and I can move to going through the home screen and creating a model. These are jobs I've run. If I've been shared another sort of job for a step in the workflow from my team, I can obviously search for those. Let's say we'll just take this top one and go ahead and generate a model. And with Azure Machine Learning, that process kicks off instantly. We've got API abstractions and integrations in there to just make this work. That model's going to train. It's going to take minutes or maybe even a couple hours. But when I think about how long it would have taken me to code and train and optimize a custom data pipeline out of the chute, or how long it would have taken me to label 3,000, God forbid, I had to do it myself, 3,000 tweets. I've saved many hundreds of man hours at this point. And I'll say, so let's go ahead and select that the first model that's ready. This is about similar size model, as we'll see from the original job that we ran that was off of that same design. So from here, this is the training data, and I'm getting a sense of some of the labels that the machine is predicting. I'm usually most interested in the lowest confidence ones, of course. See what it's getting right, even when it's not very confident, and also what it's getting wrong. And in these cases, especially for a small model like this, don't want any noise in the data. And so I'm going to get rid of any spurious examples I might have here, or correct any important edge cases where there's only a couple tweets, or social media posts around that, and just add data after I make those corrections if I want. We'll go more deeply into that, but right now my interest is getting this workflow up and running and getting the business some answers. So I'll go to the next step. So this is the route step, and this is really key. This is where the human in the loop and the human in the loop workflow starts to really tie together and manifest. So this is the point at which I define my standards of quality based on the confidences of the predicted labels that I'm getting back from the machine, and decide what's adequate and what's not adequate, where I can get an automatic label, or I want to send this for further review by humans. And so in this case, as is mostly the case, not all labels are created equal, so I'm not going to make a peanut butter assertion about what the level of this confidence threshold should be. I'm going to expand and take a look at both for that parent question around airline sentiment. This is not a terribly sensitive subject, obviously, so 80% might be a good over-under. Let's sort of see where that gets us. And then for those negative reasons, I know that some of those labels might be either ambiguous or they might be under-collected because it's only a subset of the data. So I think I'm going to add an exception there down to the label level. For instance, there was one in there, I believe, that was can't tell. And if you can't tell, then we probably want a human to see if that truly is ambiguous or if that's just something the model's not doing very well. Let's say I want that to be a higher threshold, so more of these rows going to contributors will make that 90. And then if I save that set of thresholds, I will actually get back an estimate based on the training data of what similar data sets that I would now predict would get me in terms of immediately completed rows automatically by the machine versus the ones I want to route to the humans. Now, for a small model like this, we're going to grow that and optimize that over time for our risk reward against sort of the error rates and all that. So after I do that and I upload data and predictions, I'm going to get copies of jobs created where these unconfident rows are going to go to the humans. They're going to be exactly formatted the same way. I'm going to get those job IDs and be able to bring them back into this model and retrain it over time. And this is where we're really getting the right tool for the job, and it starts to be magic. So we started on that first demo row, or that first one, about 3,000 tweets, pretty good, 76. That's, again, within industry standard benchmarks. Not so good on the negative reason. But then after I've added a couple more of these routed jobs over time, go ahead and expand that. I've got that up to 84% and 71% with a little more than the total amount of the data already. So that's pretty compelling. I could obviously do way more of that over time, even at these numbers. But let's say, for instance, this is starting to level off. It typically does somewhere. And when it does that, I want to see what else I can do. More data, cleaner data is great, but maybe there's something about the algorithm that I can learn or optimize in terms of the data pipeline or the algorithm. And so what I see here is some analytics that we have out of the Azure ML integration. And the confusion matrix, of course, for the non-data scientists, is the layup of the actual gold standard training set labels versus what was predicted. And we see that we have a little bit of a problem with neutral there. It's over half of the time right, but it's overclassifying into negative. That might be because it's not an evenly distributed data set. Could be just ambiguity. And I can also scroll down and take another look at some of the other key statistics and a little bit of a sense of what's driving individual labels. If I want to change that up, I can get a sense of what's leaning the model towards or away from the particular label it's choosing. So there are a lot of opportunities that start to tee up here, but at this point I want a little peer review. So Nick, what would you do in this situation?
Well, when I look at this confusion matrix here, I notice as well as you that we are not performing as well on the neutrals compared to the positives and negatives. And it's possible that that's due, it's virtually certain that that's due in part to imbalanced training data. We have about 3 times as many examples of negative labels as we do of neutral or positive. But I also suspect that that might not be the full story here, because if we look at the positive labels, well, those are actually accumulated at about the same level of frequency as the neutrals. So, I've worked on sentiment analysis a lot. I've actually helped build other sentiment analysis tools, and I've collected a lot of sentiment data. And one thing that I've noticed over time is that typically you will see, depending on the nature of the data, depending on the nature of the task, annotator behavior will tend to skew either strongly towards labeling things as neutral or strongly away from labeling things as neutral. And it's entirely possible that some of the things that we're accumulating as positive and negative here are actually these sort of edge cases. Now, you'll recall, as Jack mentioned earlier, that when we're collecting this data, all of these tweets are redundantly labeled by 3 people, and that means that we're aggregating over those multiple labels to produce a single label for each item in the training set. So those aggregations also themselves have a confidence score associated with them, based on things like how much consensus there was across people and what we know historically about the performance quality of the actual individuals that labeled those tweets. So I may want to consider taking some of those lower confidence aggregated labels that are currently positive or negative and remapping them to neutral, retraining the model, and seeing if that sort of levels out my performance across the confusion matrix. It would be an interesting experiment to be able to do that. And because our integration with Azure Machine Learning Studio is very transparent, it's also quite easy to do this with the click of a button. I just jump here to configure to AML Studio. And I get taken directly into this Azure workspace. So this is probably a view that is familiar to some of you in the audience. It's probably a view that is new to some of you in the audience. So for those of you that haven't seen this before, what we're showing here is not just a machine learning model. What we're showing here is actually an entire data pipeline, from the initial ingestion of that data via API integration from the Crowdflower system, going through a series of pretty standard data cleaning and editing steps, all the way down to training a model, cross-validating that model, and producing various types of output. So one thing that I really like as a data scientist about AML Studio is that it has really good support for open source tools like Python and R. And I can write up quick scripts for data manipulation and just insert them directly into the pipeline. So if I want to mess around with, say, remapping some of these lower confidence labels to other things, I can just whip up a short R script, put it in somewhere near the top of the pipeline, change those labels, save it, pop out, retrain it, and see what my results are. So that makes it really very delightful for me to use and quickly iterate not just on the sort of model data collection, but also on the data pipeline itself. Lots of really good built-in resources here as well, text analytics, machine learning, and otherwise. And I can also sort of have the freedom to build my own stuff. So I like that a lot. Now I'm going to hand it over to Gökhan to tell us more about this. He's the expert about this ecosystem, and he's going to tell us more about some of the features and resources that he's most excited about.
Sure. Let's switch to presentation view for a second. Well, first of all, thank you both for showing up here and doing the cold demo for us. Well, it clearly makes us very happy when our partners build this kind of innovative experiences for their customers, and it makes us proud. So in this specific solution, the sentiment analysis application we just looked at, Crowdflower is basically leveraging built-in capabilities in Azure Machine Learning. They were able to build a very simple data pipeline using some of the built-in modules like clean this missing data, pre-process text, edit metadata, and also able to extend that actually through their own custom R and Python code. Azure Machine Learning also enables you to actually try different featurization mechanisms, try different models. So they used the text processing capabilities we have in the system to basically optimize for the specific use cases, for the specific templates that they are building for their customers. One of the key things with this whole experience for us as we were developing this was the ease of operationalization. They were able to just take that model that you just saw and with a few simple steps, actually publish it to production, scale it in a world-class on a world-class service, and also just get two web service endpoints for interactive and batch execution, and integrate seamlessly within their own service. Remember, these are two different services, geographically separated, and they're integrating very well together and providing a very seamless experience. So that said, they only use the subset of the capabilities, and there's a lot more obviously in Azure Machine Learning Studio in terms of the capabilities. And you might be thinking, oh, this is all just presentation talk. It can't possibly be that simple. So what I'll do is actually I'll be brave enough to get into Azure ML Studio right now, start with an empty blank canvas, and we'll build a Twitter sentiment analysis model right now, right here with you. So hopefully everything will work out. Keep fingers crossed. Can we switch to the demo again, please? Did you switch?
You're on.
All right, great. So what I'm going to do here is just create, this is Azure Machine Learning Studio, and the first thing I'm going to do is actually create an experiment. This is my canvas for actually doing the machine learning art. So the first thing that I need, obviously, is data. And if you look at the data input and output capabilities of Azure Machine Learning, we give you a bunch of capabilities to ingest data from many data sources, whether it's Azure storage itself or external data sources through HTTP or OData, even on-premises data sources such as on-premises SQL Server. Well, for the sake of the demo, just to be efficient, I'm not going to ingest data, but I'll use a data set that I have already uploaded into my workspace. And I'm going to just drag and drop that data set. It's a 2.5 megabyte Twitter sentiment analysis file. And let's look at what's in the file, just to make sure you don't think it's fake data. So you see there are two columns, real tweets, a sentiment label, and a tweet text. And if I click on any of the columns, Azure ML gives me the ability to visualize what's in the data, gives me some key statistics about the data so that I can understand it better. And it generates graphs that represent your data structure. Now, clearly, this is just a label, so there's not much interesting. But what I'll do next is build a data pipeline, because I would like to do some data cleansing. And I'm going to go to Data Transformation tab and basically pick up Clean Missing Data module. Trivially, it basically cleans missing data. And I'm going to choose how I'm going to clean the data. I would like to remove the rows that have missing labels or text. Once I'm done with that, since we're doing text processing, I'm going to use a specialized module for pre-processing text. And let's look at what that module does real quick. It basically gives me specialized capabilities to remove stop words, remove numbers and unwanted characters, describe sentences and whatnot. So I'm not going to do any configuration, actually. I'm just going to use the vanilla out-of-the-box experience. So let me tie my clean missing data to the preprocessed text module, and I need to tell this module what column I would like to process. Let's use, well, tweet text. You see the pre-populated column names. And I think I'm actually now ready to featureize my sentiment, the Twitter sentiment. So as you see in the text analytics, simple enough, there's a feature hashing module. I'm going to drag and drop that, and I'm going to feed my data set into the feature hashing module. I'm going to use the default configuration, not changing anything, no optimizations, and I'm going to tell what column I would like to featureize. And in this case, it's the tweet text, and hit OK. And I'm actually ready to train a model. I processed my data, I featureized it. Now I'm going to feed it into a machine learning model. In this case, I'm going to use the multi-class decision forest. Well, I can search for decision forest, and I can drag and drop that to train. And I'm going to use cross-validate module that basically takes your data, takes the trained model, and actually trains the data, creating folds, basically splitting your training set and scoring set. So, well, it takes the data, and then it takes the algorithm. We're almost there. And cross-validate, let's see what it asks me. It asks me for a label column, and I need to give it basically the label to predict. It's the sentiment label. And, well, the last thing I want to do is once the model is trained, I would like to evaluate the model, see the results. So I'm going to search for evaluate model, and I am actually done. So once I hit run, this execution tree will be represented on Azure Machine Learning. It's be split into multiple code paths, run on a scalable service, and it will give me results. So I'll hit run, but I'm going to use the same cooking show analogy. But in this case, I'm actually going to microwave it, not just pull it out of the oven. I already have a trained model that has actually cached data, so it's not going to do all the cache, the data pull and processing. It's already done that. And this is exactly the same model we just built. It's going to return much faster, and I'm going to let the other one cook. So let's see what happens in this model real quick, very fast. The reason we get very fast results is Azure Machine Learning already ran it, cached a bunch of stuff. It knows a lot about the experiment already, so it returns really fast. So let's look at the results. Well, I got about 67% accuracy on negative sentiment and 51% accuracy on this model on the positive sentiment. This is your matrix, and overall 60% accuracy. So it took us about like 2 or 3 minutes here, right? Well, the beauty here is that I think I can actually do better. So what I'm going to do is, I'm just a curious person. I'm going to try logistic regression and see if logistic regression actually gives me any better results compared to the decision forest. I do the exact same magic and get my data, feed it into cross-validate, and evaluate module will actually run these 2 experiments and then the branches, and then compare the results of the trained modules. Again, I can hit run, but I already have a run version, so I'm going to microwave this one real quick, and it's going to return us the comparison between the 2 models. All right, let's give it a second. Check, check. You must be happy when you see green check marks, obviously. So let's look at the new comparison. With the logistic regression, I was actually improve both the negative, well, I think the negative predictions mainly, but we went from 50% to 67% accuracy. And I haven't done anything special, guys, just drag and drop built-in pre-configured modules so far, right? And again, I'm a very curious person. I'm thinking maybe if I featureize the data set differently, my text, I might get a different result. So what I'm going to do in this case is I'm going to actually modify this experiment. Let's get rid of the decision forest because that's not the model that I want to use. I'm going to copy paste a multi-class logistic regression module, and I'm going to use a special module called extract ngram. Again, this is in the text processing, text analytics section. I'm going to pull this in. It's at this, I'm just going to featureize the text again. So let's do this. It takes the data. It asks me what column I would like to process. I'm going to just choose. So this is the preprocessed tweet text that's coming from the preprocessed text module. And I'm going to feed this data. Well, not now. This cross-validate will require this data set. Okay, and to make it the same as the feature hashing module, I'm going to choose the n-gram size to be 10, and also not eliminate any features. Okay, so we're all set. I'm gonna, well, if I hit run again, this is going to take a few minutes. Same microwave trick, and then I'm going to run this exact same model now that I ran right before the demo, and let's see what comes back. So one thing that you realize is I tried 2 different models, 2 different featurization mechanisms in a sentiment analysis application in minutes. I didn't do any special configuration. And let's look at the results. Well, I'm able to get to 78% accuracy on the positive sentiments and 69, 70% accuracy on the negative sentiments. I'm better than your industry average just by just doing nothing. Nothing but just dragging and dropping modules. And as I said, I'm not even a data scientist. I may not even know how to optimize these models, but I was able to build a true Twitter sentiment analysis application in just minutes here. If you see a few magic buttons at the bottom, when I click on Set Up Web Service, Azure Machine Learning actually creates a deployable web service for you. And once I'm going to run this again, and it's this easy. I'm going to just hit another button, and this is going to be operationalized in production at production scale. There we go. The magic is done, and I'm going to deploy my web service. I'm done. My machine learning project is done. And any consuming app now can actually use my endpoints to score their data using the request response or the batch execution service endpoints. This is it. I'm done. I have a fully functional, operationalized machine learning experiment in the cloud right now. This is exactly what actually Crowdflower did. It's not much more than this, except for some custom code that they had to write for their business logic. So if you could go back to the presentation mode. Can we go back to the presentation? Oh, all right. So we did build the model, and we did do the demo. The great thing here is not just that we were able to build a model in minutes and deploy it. Actually, I'm a product manager with development background for the last 15 years, and I have never built a data science project end-to-end in my life until the last 6 months. And this product actually made me brave enough to show up in front of hundreds of people and actually build a machine learning experiment and operationalize it. I think that's actually the astonishing part. And when we say democratize machine learning, that's really what we mean. We're trying to enable data scientists and application developers not to worry about this kind of things, but build actually more innovative experiences, kind of taking the fat out of the meat. So to wrap up our conversation today, when we look at the Azure Machine Learning and Crowdflower integration, we honestly think it actually opens up new frontiers for building the next class of AI or machine learned applications. Leveraging machine learning, human intelligence will actually make our models more powerful, more accurate. And these 2 systems actually give you a way to get high quality in-domain data, labeled data, and use a very simple machine learning and operationalization platform through Azure Machine Learning. And not only that, but actually continuously improve your models and applications through reiterative training without disrupting your existing users or applications. Well, thank you so much for listening. I think we have about 4 minutes to take some questions, and we'll be around if you have any questions. Thank you. Well, thank you, sir. Appreciate it. Thank you, Jay. Thanks.
If you have questions, please use the microphones. Thank you.
One.
Hey, thanks for the presentation. That was really nice. My question is, there will be a lot of instances where multiple topics are discussed within the same tweet. For example, if we take the same Delta example, I could be talking about, say, in-flight experience. And I could say, I had a great cabin crew, but the food options weren't as good. This technically becomes a neutral sentiment because we had one positive and one negative. Yep. But is there a way where we can say Delta scored a positive on food, positive on cabin crew, but negative on food?
Yep.
Yeah.
You want to take that?
Sure. Yeah, no, that's a great question. That's definitely something with a little bit more of a nuanced job design that you can build. The model that we had here was just based on a set of mutually exclusive options that we were classifying along. But we also can support data collection with multiple labels per row using things like checkboxes, and then that would be a matter of training probably a larger set of binary classifiers on each of those, and then that would allow you to sort of more fully cross topic area and sentiment in your documents. Yeah.
And conditional questions, I would say as well. You can say, is there more than one thing mentioned in this, sort of branch it the similar way I did it? We can do it with workflows from job ID to job ID and fork the data that way. So yeah, it's really about your definition of quality, whether or not the contributors need to get all of the labels or some of them if you're allowing multiple. But yeah, pretty infinitely customizable that way.
The one other thing that I would add there is that this is actually a perfect case for routing some of these items to humans for review, who are going to have that more nuanced way to tease apart if there's mixed sentiment within a compact document like that. That's exactly the type of insight you could leverage to really get at that more accurately.
I was wondering, I didn't understand exactly on the backside. Is this like an Uber model? Do people just sign up and say, hey, I want to be a sentiment analysis person for 2 hours a day? Or do you get specific domain knowledge, or can you ask for specific domain knowledge?
Sure. So we have done a ton of that sort of thing, specific things. I mean, in sentiment analysis, we've done a fair amount. Even Nick's done it as well with, for instance, gaming slang is something that's very particular. And usually and it's certainly U.S. specific in a lot of cases. And I would say in most of the cases, the mechanic is still observed accuracy with the work against the business rules that you lay out. But we have also cultivated and defined certain crowds. We've integrated specific BPOs for customers that they're already working with so that they can manage the quality and monitor the quality the way we have it on the platform. So it really depends on the need. We're generally able to customize for it.
Okay, great.
I would just add to that in the past, one of the things that I've done, now in the case that the data is sensitive and you want to work through a particular BPO, people under NDA, we support that. But on top of that, you can just construct test questions that would be very hard to answer with consistent accuracy unless you had that domain knowledge. And the people that aren't qualified to give comment on that would just fail out of the job very quickly.
Yeah.
Okay.
Yeah.
As far as scaling up the human-in-the-loop component for large data sets, do you have a workflow for, say, recommended sampling or what to show the user to get that good feedback?
That's a great question. In terms of the data that you upload into contributor jobs, that's really up to our customers to manage that side of their data project, though we can have conversations with them around that. In terms of throughput, though, I mean, the Crowdflower platform just cleared the 2 billion human judgment mark, and millions per week is, the wings aren't even shaking for us. So there's also quite a bit of scalability inherent there. But if you had truly very large data, doing something like a stratified random sample is always a good place to start.
Thanks.
Cool. Thank you.
I didn't see it in the product offering, but do you have entity extraction and lexicon development within your platform?
So we do support entity extraction via the human contributors. In terms of named entity recognition models via the Crowdflower AI solution, that's something that's on the roadmap, but that we're still working on. And that's something that we're having conversations around with the Azure team as well. But that requires support for things like conditional random fields that we're still working towards.
Thank you. We're almost out of time. So we'll be around to take further questions.
Come see us at the Meet the Speakers session. We'll be heading over there right now.
Thank you so much. Thank you.
Thank you.